All right, welcome back. Today we're looking at 5.3 part 2. I'm sure you are already aware and you're just waiting for me to start, so let's do it. So, this says we're going to do a recap of day 1. That is a lie. Now that my lessons are in video format, if you want a recap of day 1, you can just go back and look at day 1. Not to mention it should have been like yesterday, right? It should be okay. Or maybe you're trying to double up and doing multiple lessons at once. That'd be sweet of you. That'd be really great of you. Anyway, unless you're procrastinating, unless you're waiting until the due date and then doing it, that's not good though. Anyway, whatever. So today we're looking at complex conjugates and dividing two complex numbers. Are we really doing that? Wow. All right, so we got a lot on our plate. So complex. Don't write any of this down. This is that recap business. So complex numbers. They've got a real part and a complex part, right? And then you can add and subtract them, right? And you can multiply them. So here it'd be like -4 minus 8 would be -12. I minus -3i. That'd be a positive 4i, right? That kind of thing. Now, a complex conjugate. You should write down all of this. Now, if a complex number has the form a plus bi, the complex conjugate of that number is a minus bi. Basically, the big change is that the sign of the complex part will change. That's it. The sign of the complex part changes. So let's look at a couple of examples. So we've got -3 plus 4i. So the sign of the complex part should change for the conjugate. So the complex conjugate, the sign of the complex part will change. So this will be -3 minus 4i. Simple as that. So the next one, 2 minus I, here's the complex part. The sign changes, 2 plus I. You try to do the next two. The sign of the complex part will change. So look at it. Maybe say it to in your head. What is this going to be, the complex conjugate? Well, -32 minus 11i. If you said that, you're correct. And how about this? What would this complex conjugate be? Well, this should be -6i because that's the complex part and it's positive, and so you should make it negative. And technically, this is 0 plus 6i. So your complex conjugate would be 0 minus 6i, right? Hopefully that explanation made sense. And you might be thinking, okay, why? Why do we mess with the sign? What's the purpose of the complex conjugate? And it has a great purpose, I think. It's another one of those amazing math discoveries or inventions that really helps us solve problems. And it is so amazing at getting rid of like complex. It is like an I eliminator, and we'll see why. Right? So why do we need conjugates? So you should not write this down. You should not write any of this down. All right. This is just me explaining to you why we need conjugates. So if you look, the answer to this problem needs to be simplified into a complex number. To manipulate this further, you need to get this into a format where it's a real part plus or minus, depending on the sign of the complex part, a complex part with I, right? This is what you need. This is not what you have. Like, you need to do something here. This is a problem, right? You've got a complex number divided by another complex number. But using conjugates, you can actually get it into this format. And let's go ahead and try to do that. So, here's I didn't know this was coming up, but this is a piggyback on that previous thing. So, if the denominator was not a complex number, but instead it was a real number, like 85, then what you could do, so if the denominator was a real number, again, you don't have to write this down. If the denominator was a real number, you could split up the numerator. See, the numerator is a complex number, but if the denominator is a real number, then you can split this up into 3 over this number and then minus 5i over this number. And the minus 5i would be written out like this. And so you've got your real part and your complex part. This is a complex number. So what we need to do is we need to find a way to make the denominator a real number. And that is where conjugates come in. All right. So if you're not on this boat yet, like if you were thinking, what in the world is Mr. Dowell talking about? uh, try not to have a defeatist attitude, right? I've seen so many students just really kill themselves in their own grade in my class by having this defeatist attitude, this attitude like I can't do it and I'm going to prove I can't do it by not doing it and having a mental block. All right, that's not helping you. That's not helping me. Your negativity just annoys me and it hurts you, to be honest. So, try to have a positive mindset. I certainly have a positive mindset when I'm teaching you. All right. So, using conjugates. Now, here's the idea. I would also not write this down. I would write this example down. I would write multiply the complex number by its conjugate. So here's the complex number. What is its conjugate? Well, if you remember right back up here, you were probably pretty proficient, pretty good at remembering what to do here to make these conjugates. Well, let's do that same thing. So let's multiply this complex number by its conjugate. Its conjugate happens to be 3 plus 5i. So we're going to multiply these two things together. And so you're going to distribute, and then distribute, just like you would just like you would if they were x's, right? So the 3 times the 3 is 9, right? The 3 times the 5i is a positive 15i. Now here's where the magic starts to happen. The negative 5 times the 3 is a negative 15i. Ooh, interesting. And the negative 5i times the positive 5i is a negative 25i squared. Because I times I is I squared, and positive 5 and negative 5 make a negative 25. So when you simplify this, remember, I squared is replaced with negative 1. And the 15i minus a 15i, those cancel out. And all you have left is 9, and then minus 25 times negative 1 here. And negative 25 times negative 1 is a positive 25. And so you have 9 plus 25, which is 34. So what we did was we took a complex number, and when we multiplied by its complex conjugate, it gave us just a single real number. We took two complex numbers, multiplied them together, and it gave us a real number. This is what we need. Remember, if we can make this denominator a real number, it will allow us to create, to simplify down to a single complex number. So that's what we want to do. So here is the shortcut method. All right. Now, again, we had a shortcut method for squaring a binomial earlier. I don't know where that was. I think it was in day 1 of 5.1. But today we're going to look at a shortcut method for a complex number times its conjugate. And it's really simple. The shortcut is just the first term squared plus the second term, just the number squared. So the first real number squared and the second real number here, the real number piece squared. That's it. So if you try to multiply this by its conjugate, right? I know it says you try, but we haven't seen it before. So just try to follow along with me and make sure that you could repeat it if you had to. So the conjugate, you should be able to tell me that. Tell me the complex conjugate of negative 2 plus 3i. You should have said negative 2 minus 3i, right? So I'm multiplying this times its complex conjugate. Okay? And so all you want to do, the shortcut, just say take this 2, don't even worry about the negative, just take 2 and square it, and add that to 3 and square it, or add that to 3 squared. So it's the shortcut is 2 squared plus 3 squared. Simple as that. 4 plus 9, which is 13. Boom. Look how quick that was. None of this distributing, none of this simplifying, none of this changing I squared to -1, none of that. It's just first number squared, second number squared, add them together. And it will work out. All right? So, let's go ahead and learn how to divide complex numbers. Now, you should write down all these steps. You maybe not have to write the word step every time, maybe just 1, 2, 3, or steps, and then 1, 2, 3. But dividing complex numbers is going to be one of the things that's on your upcoming test, as everything else is that I show you. So, better learn it. And to be honest, I'm pretty positive that I'm going to structure this where 5.1, 5.2, and 5.3 will all have their own, like a quiz for them. So you should have a quiz coming up if I'm scheduling this right. So the first step, multiply by the conjugate of the denominator over the conjugate of the denominator. So when you're dividing complex numbers, you have a denominator here. Even if your problem looks like this, even if your problem looks like this, really, this can be rewritten as a fraction. Okay, so I want you to be aware that this problem right here, this division problem, is exactly the same as this right here. So if you see this, write it in this form and follow these steps. So you multiply by the conjugate of the denominator over the conjugate of the denominator, okay? So let's go ahead and do that right now. What is the conjugate of the denominator? Well, the conjugate of the denominator, I know that's kind of a thing that's hard to say over and over. It's 2 minus 9i. The sign on the complex part changes. So you multiply by 2 minus 9i over 2 minus 9i. Okay? And what happens is you need to simplify now. So you've got two complex numbers multiplied by each other and two complex numbers multiplied by each other. And remember, this is taking one fraction multiplied by another fraction. And to multiply two fractions together, you just multiply the top times the top and the bottom times the bottom, right? So this is where you need to use, you don't need to, but it'll make things quicker. Use the shortcut for the denominator. So remember, in the denominator, you're just multiplying a complex number by its conjugate, so that follows this shortcut. So let's go ahead and do that shortcut real quick. And I'll use yellow here. Go ahead and do that shortcut. It'd be the first term squared. So I'll do this. I'll do this in a different color. How about this teal? 2 squared plus, so that's the 2 squared plus the 9 squared. So that is 4 plus 81, which is 85. Boom. So this is 85. Wow, that was quick. Now this next piece, you need to just go ahead and work out. So I'll do that over here. You've got 3 minus 5i and 2 minus 9i. And now you distribute. So distribute. And so you're going to get 3 times 2, which is 6. 3 times negative 9i, which is negative 27i. Negative 5i times 2, negative 10i. And negative 5i times negative 9i, which is a positive 45i squared. Now, the negative 27i and the negative 10i make negative 37i. And the I squared will make this piece negative. It basically flips the sign because this is negative 1. The I squared really equals negative 1. And positive 45 times negative 1 is negative 45. So you have a negative 45 here. And then the 6 minus the 45 gives you negative 39 minus 37i. And so this is negative 39 minus 37i. And now what you can do is you split into real part and complex part. So the negative 39 you place over 85, negative 39 placed over 85, and the negative 37 you place over the 85, and then you write I. Okay, so there's your problem complete. And I know that might have been a lot to take in, but we're going to do another example. So try, like I was saying, to have a positive attitude. We're only 15 minutes into the lesson, and this is the last problem. So, it's only going to take another 5 minutes maybe, and then you'll have the rest of the class period, maybe 25 minutes, another like double this time to work on homework and ask questions and that kind of thing. All right? So, let's go ahead and do it. And if you are, just keeping up and doing this, that's amazing. I'm really happy about that. I'm happy you're getting use out of this. So multiply by the conjugate of the denominator over the conjugate of the denominator. So what is the conjugate of the denominator? That's 6 plus 4i. So you go ahead and multiply by 6 plus 4i over 6 plus 4i. So again, use the shortcut method here, and then go ahead and FOIL this out, and then split it after you simplify. All right, you guys try to do that, and I'll go ahead and work this out as well. You can pause the video, and then I'll start working this out quickly. So I'm going to reserve this for the final answer. Here, the shortcut method, it's going to be 6 squared plus 4 squared, which is 36 plus 16, which is what, 52? So that's 52. And then you've got this business up here. So that's going to be 8 times 6 is 48. That was one of my hardest ones learning when I was in grade school. And then 8 times 4i, which is 32i. And then I times 6, which is 6i. And I times 4i, which is 4i squared. These two pieces combine to give you 38i. And then this over here makes negative 4. So you've got 48 plus 38i minus 4. And so you have 44 plus 38i, giving you 44 plus 38i here, giving you, when you split it, you get 44 over 52, which could be reduced if you wanted to, and 38 over 52i. Make sure I didn't do that wrong here. Let me look. Double checking my work. No, that looks right to me. All right. Your homework is, obviously on your screen. Hopefully you did this okay. And I just want to point out that these fractions can be simplified further. You could do this as like 22 over 26, which would be like 11 over 13, and then this would be like 26 on the denominator and 16 on the numerator, and this would be 8 over 13i. All right, that would be a more simplified version. I just want to point that out. So here's your homework. You guys know what to do by this point. We're well through the first semester. So get started.